All right, guys, this recording is for section 12.1. The title is called Sequences. So we are going to start out with defining some of these vocab, and then we can move on to a few examples on the bottom, okay? Okie dokie, here we go. Sequence is a function whose domain is the set of all positive integers. Is the set of positive integers. Series is the sum of all the terms of a sequence. Is the sum of all the terms of a sequence. All right. So we have the word terms. Terms are the numbers in the sequence. Terms are the numbers in the sequence. Factorial symbol. Usually we use this symbol right here. So n factorial, meaning that it's n times n minus 1 times times 3 times 2 times 1. Okay, so if I don't want to use the dot, I can use parentheses to represent multiplication. For n to be greater than or equal to 2, because there are some special things with factorial. If n is not 2 or greater, like n is 1. So if it's 1 factorial, it's really 1. Also, if it's 0 factorial, it's, guess what? It's not 0, it's also 1. Okay. Now, so factorial, it's really factorial is going back to probability. Okay. So if you have 0 factorial, that really means how many ways, okay, how many ways can you arrange 0 items? Well, there's only one way, okay? There's one way to arrange 0 items. It's just because what happened when we have nothing to arrange, okay? There's nothing. Then 1 factorial really means how many ways can you arrange one item? Well, one way to arrange one item. So for example, you have one book. How many ways can you arrange one book on the shelf? It's just one way. Now, what if you have 2 factorials? Okay, so what if n is 2? This means you have 2 times 1, which is 2. Okay, that means how many ways can you arrange 2 books? Well, there are 2 ways. Okay, so you got one book go in the front, let's call it book 1, and then book 2 go in second. Or, that's one way. Or you can arrange it, book 2 go in the front and book 1 go in the back. So there are 2 ways of arranging it. So n factorial, think of it as how many ways you can arrange items if you are in probability and AP Stats class. Okay, but in here, we're just gonna calculate the number. So what if I ask you to find, like, for example, i.e., 8 factorial, okay? 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's a huge number, okay? 8 factorial is a ginormous number. It's 40,320. So that's what 8 factorial is, okay? So how many ways can you arrange 8 books? Take a wild guess. You're right, 40,320 different ways. Okay. Now, so here is a question for you. Do you think 10 to the 100th power, which is called Google, is it bigger than 70 factorial? Okay. So the next time I see you, you can give me an answer. And if you have a graphing calculator, is it possible for you to do 70 factorial in your calculator? Okay. Do you even know where the factorial symbol is? Okay. So try to figure that out with your calculator. If you don't know where the factorial button is, you can totally ask me in class. Okay. Next, recursive formula is a sequence. That requires you to find the values of all previous terms in order to find the value of a sub n. Okay, so recursive formula is a sequence that requires you to find the values of all previous terms in order to find the value of a subscript n. What that means is that if you want to find the fifth term, that means you have to find the first four terms first. Okay, so that's what that means. Fibonacci sequence. Okay, it's really well known. Most movies that you watch that has a little bit math involved, they always bring this up. Okay, is a series of numbers. Starting with 0 and 1. So, comma, starting with 0 and 1, where a number is found by adding up the two numbers before it. Okay, so Fibonacci sequence is 0, 1. Okay, for you to find the third number, it will always start with 0, 1. And it will always be the same sequence because it has a name. It has a Fibonacci sequence. That means it's created or was created by Fibonacci. So the third digit is going to be 1. The fourth number is going to be 2. Remember, you're always adding the first two numbers. So the next one is 3, the next one is 5, the next one is 8, the next one is 13, and so on and so on. Okay. Summation notation is a concise way to express the sum of a sequence. So let's say that I'm going to give you a sequence such as this. So IE, okay? IE. A1 plus A2 plus A3 plus, skip a few, plus A sub n, okay? Mathematicians were quite lazy, I would say, right? Because we just want to think and we want to come up with creative ways to do math. So instead of writing it out like 100 times, that's a waste of time. We don't have time to do that. We need a shorter way to write that out. So what's happening is the bottom number right here. Okay, so I want to start at the bottom. And first let's talk about how do we write this summation notation. Summation notation is like an E, like that. Do an E like that, okay? The bottom number, is, you're telling me what you're starting with, okay? So K equals 1. That means my first term is 1. Then and then on the top is where it ends, okay? So This is where it ends. This is where it begins. Okay. And then on this side number here, which I'm going to write in rainbow, is what do I do? What do I do to get all of them? Okay, so A subscript K. So if K is 1, then that's my first term. If K is 2, then that's my second term. If K is 3, then that's my third term. If K is N, then that's my nth term. So this is a quicker way to express the sum of a sequence. Okay, let me give you another example. So another one, let's do 1 square plus 2 square plus 3 square plus 4 square plus, skip a few, 9 square. Okay, this one, we know where it ends. So I'm out of space there, so I'm going to go over here. So how do I write the summation of this sequence? We write the big capital E looking symbol. I will start with K equals 1. No, K doesn't always have to be 1. K can be 0. K can start a different number. Okay. When K is 1, okay, and then that's my beginning value. Now, where do we end? We end at 9. So we don't have N on the top because now we know where we end. The last number is 9. Now, how do I get each digit? What happened is when K is 1, I would have 1 square. When K is 2, that's my second term, right? When my first term is 1. So what's happening is, hey, what can I use? Over here is sort of the formula. So what you just do is just write K squared, because each value of K you put in, that will give you each term until I go to K equals 9. Then that is my last term. Hence, this is the end of it. And this is the beginning. Okay, so you got the end and you get the beginning. Properties of sequences. Okay, we have 4 of them. So here we go. If the set of A sub n and the set of B sub n are 2 sequences and C there you go, and C is a real number, then here we go. Case number 1. The summation of K equals 1 to the nth term of C times A subscript K equals, so if I give you the summation of starting at K equals 1 and it ends at nth term, and C, according to this definition here, C is a real number. That means it can be anything it wants to be, okay, and times A subscript K. Then this is the same thing. It's just saying C times A subscript 1 plus C, whatever C is, times A subscript 2 plus, skip a few, C times A subscript n, okay, which is the same as taking out your C, because that's what C is. They all have C in common. It's just that real number. Then we can just go ahead and add A1, A2, skip a few, A sub n, okay, so those are equivalent. Well, if those are equivalent, that is also equivalent to the summation. Again, K starting at 1. It's the same thing as adding all the A's first, then multiplying by C. Okay, and we end at nth, and it's going to be A subscript K. So what this is saying that, hey, if I have C, the summation of C, A subscript K is the same thing as saying that do the summation of A subscript K first and then times it to C. Okay. 2. The summation starting at K equals 1, it ends at nth of A subscript K plus B subscript K, okay, in quantity. Then this is the same exact thing as if I were to break it up as two summations. Okay, so it has this property. So these are the rules. So if you have the summation of a subscript k plus b subscript k in quantity, then it's the same thing as I can break these out. Okay. Number 3, I'm just going to write it over here because I'm kind of out of space. If I have the summation k starting at 1 to the nth power quantity of a subscript k minus b subscript k. It's very similar to your addition. I can break this up into summation of k equals 1 to the nth of a subscript k, take away summation of k equals 1 to the nth of b subscript k. Okay, so the addition of summation and the subtraction of summation, you can break it up. And for our last property of the sequences, if I have the summation of k equals 1 to the nth power of a subscript k. This is, oops, my bad, we don't start at 1 anymore. Of things that don't start at 1, okay? Like j plus 1, okay? And j, it's whatever it wants to be. And then we're going to define j in a little bit, whatever positive number, I should say, that it wants to be, okay? So again, the summation of k equals j plus 1. What this is really meaning that I don't want it to start at the value of 1. Then I can turn it into, what if I want it to start at 1? In a little bit, we are going to do problems that things don't start at k equals 1. And usually we want it to start at 1 because it's easier, right? But sometimes that doesn't really happen. Okay, so how do we bring things back so that way it can start at 1? Then here's the rule. We will do summation of a subscript k starting at 1 to n minus the summation of k equals 1 of a subscript k to j. Okay, and what on earth is j? Where j is greater than 0 and less than n. Okay, so let's say n is 9. Okay, that means j can be 4. So that means this is really starting at 5, right? If j is 4, well, I don't want it to start at 5. Okay, I want to count starting at 1. Then I can start from 1, okay, to 9, and then take away, oops, I didn't finish writing. This is k equals 1. Okay, take away 1 to 4. Okay, so that gives me 5 to 9. That's all that is. Okay, and if this is confusing, it's totally okay. We will do problems, and that will be using these, just like all of our definitions. At first, it sounds scary and it looks scary and it sounds confusing, but it's just a language. Once we put it to use, they will make a lot more sense, okay? All right, formulas for sums of sequences. So we have 4, okay? These 4 you should really know if you want your life to be easy, okay? Summation. I know my summation symbol is quite ugly. I think your book does a better job like that, but I just can't do it by hand. So I'm just writing E, really. So formula for sums of sequences. That means I'm going to add up all the terms now. So starting at 1, k equals 1 to the nth power. If you just have c. Then what happens if you just have c and you want to add up all the c's? But just really what that means is c plus c plus c dot 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 plus c. That means you have c times n, okay? What is c then? C belongs to any real number. C can be 1.5, 1.2, whatever c wants to be, okay? 2. Let me just give you a quick example, i.e., okay? Summation k starting at, let's say, 1 to 4, okay? And c is any real number, so let's pick 2. So that means, what do I do with that? What does that mean? This means when k is 1, okay, my first term, when k is 1. It doesn't really matter because I just have 2. The next sequence, when k is 2, I just have 2. The next one, I have 2. And the next one, I have 2. Well, the summation, I have 4 terms because it ends at 4. The summation means I need to add all of these. Okay? So when I add them all up, it's just really 2 times however many terms I have. Okay? So this is n right here. So that's why this is 8, or c times n. Okay? So that's how they come up with that formula. All right, next. I have a summation starting at 1 to the nth, and I have k. Okay? So when k is 1, then my first term would be 1. When k is 2, then my next term would be 2. Okay? So when k is 1, it's 1. When k is 2, then it's 2. When k is 3, then it's 3. And so on until it's nth term, right? That's my dog wanting to come in, and I just can't pause right now. So what's the formula if I want to add them all up? You're not going to sit here and add, if n is 100, you're not going to sit here and put this together, okay? If n is 500, you're not going to sit here or on your calculator do 1 plus 2 plus 3 plus 4 plus 5, 500 times. So you want to come up with a formula. So the formula is n times n plus 1 all over 2. So i.e., okay, if I have the summation of k starting at 1, that's 10 n is 10, and then I just have k. So what this means is I have 1 plus 2 plus 3 all the way to plus 10, right? So instead of just sitting here and adding it all together, you can go, well, 10 times 10 plus 1 all over 2, which is 10 times 11 all over 2, which is really, we can reduce those, that's really 5. So 5 times 11 is 55. So that's kind of how we think of it. All right, 3. The summation starting at 1 to the nth, and what if you have k squared? So the first term, k squared, is still 1. Second term, 2 squared is 4. Third term, when k is 3, 3 squared is 9, plus dot dot dot, plus n squared. So just like number 2, you're not going to sit here, if n is like 99, you're not going to sit here and do it 99 times in your calculator. So you want to come up with a quick formula, so that way you can come up with the sum. The sum means the final answer of all of that. So that's the formula. There will be a class in college that you will take, or if you want to take, I should say, if you're going to be a math major, that will prove all of these, or will help you explain why we come up with all of these. Well, I think that's even in calculus. Maybe next year you will. Okay. The summation starting at 1, again, k equals 1 to n. What if I have k to the third? So when k is 1, 1 to the third is 1. When k is 2, 2 to the third is 8. When k is 3, 3 to the third is 27, and so on, plus n to the third. Well, all right, here we go. Formula for this is going to be n times n plus 1 all over 2. Well, that looks too much like k, right? So that can't be right, because this is k to the third. So what's happening is we're going to take the quantity of that all and we square it. Okay, so that is the formula to the third power. All right, and I think this is where I'm going to stop for this video.